Back when we were in kindergarten, we all used to love talking about dinosaurs and fantasize how they would look like if they weren't extinct. Of course, how they got extinct is still a matter of debate, but many scientists believe an extremely large asteroid hit Earth 65 million years ago near present-day Mexico. The asteroid impact caused disastrous conditions across the entire planet, including thick clouds of dust and ash that caused global temperatures to plummet, causing the extinction of the dinosaurs and a lot of the rest of life on Earth. Earth's orbit around the Sun is littered with innumerous pieces of debris. The chance of an asteroid impact depends on its size. The bigger the size, the smaller the chance, since there are many more small ones out there rather than the large ones. The truly dangerous objects, those large enough to cause large-scale catastrophes if they hit land masses, show up usually once every few 100,000 years. The chance that such an object will hit us in any given year is roughly 1 in 300,000, nothing to lose a lot of sleep over. Still, thankfully, unlike dinosaurs, we humans have several means to find the largest of these near-Earth objects, as we call them, and calculate whether they will ever come close enough to bother us. Several telescopes monitor and scan the sky for such asteroids regularly. Repeated observations of the asteroid lead to predictions of its orbit. Asteroids are then categorized to identify its properties. So, the question is, even if we identify such an asteroid that is projected to hit Earth, how can we prevent it from hitting Earth? Well, we can categorize the several methods that can be used in two options, either deflecting the asteroid or breaking it up. Coming to the deflection of asteroids. As the name says, this option is to deflect the asteroid such that the asteroid's orbit is changed to avoid hitting Earth. Under this option, we can use the gravity tractor method, in which a spacecraft pulls the targeted asteroid with its own gravity, thereby deviating. Asteroid laser ablation is a technique which uses spacecraft lasers to vaporize some of the asteroid matter to change its course. Scientists have proposed using focused solar energy beams as a similarly principled but more complex alternative to this. Then, there is the kinetic impactor method, where one or more spacecrafts are launched with the aim of impact right into the asteroid, slamming it with such force as to deflect it away from its projected orbit. This is the principle NASA's recently launched DART space mission is based on. The spacecraft is projected to collide with a small moonlet, Dimorphos, to test the system out. Now, onto the other method, which may seem more interesting, but is much tougher to organize and prepare for. Breaking the asteroid. We can achieve the same by performing a nuclear explosion, destroying the object. In fact, this method can be used as a method for deflection as well. In case that the object is a large one, but made up of loose matter, care has to be taken not to fracture the already loose pile of debris. However, nuclear explosives are always held as a last resort. Though deflection of NEOs might seem like the wisest option, there are some problems with it. As Carl Sagan pointed out, if comets can be deflected away from Earth, they can also be diverted onto Earth, be it threatening or not threatening. Also, in the process of deflecting asteroids, while danger on most parts of Earth would be reduced, the security of some countries might be put at risk. Well, that's that. Our space scientists do a lot more than just exploring the universe. They also do a lot for the protection of our countries. Here's to another day without being hit by an asteroid.